everyone. It gives me great pleasure to welcome you all to day 3 of our session. Today, we continue our journey of learning and collaboration with renewed enthusiasm. We extend a warm welcome to our resource person, Dr. K.Venkata Subba Reddy, Associate Professor, Department of CSE, NIT Warangal. And the topic for this session is quantum communication, entanglement and transmission protocols. As a mark of respect and gratitude, we now invite our Dean, Mr. Srinivasan, to felicitate our guest speaker with a shawl and memento. Thank you, sir. Thank you, ma'am. Dr. K.Venkata Subba Reddy is Associate Professor in the Department of Computer Science and Engineering at NIT Warangal. He has a PhD in Optical Communication and Quantum Information Networks with more than 2 decades of academic experience. He has published extensively in IEEE and Elsevier journals and has delivered invited talks across premier Indian institutes. In this session, Dr. Venkata Subba Reddy will focus on quantum communication protocols, quantum repeaters, and the challenges of long-distance quantum information transmission. We welcome you to deliver the lecture, sir.
So first of all, I thank the administration of Mahalakshmi Technical Campus, in particular Srinivasan sir, for giving me an opportunity to be part of this FDP and share my knowledge on the topic. Thank you very much again, sir. Thank you, sir. Dear participants, so we try to make this lecture as much interactive as possible. So whenever you have doubt, you can interrupt me and you can ask me. Okay? Sir?
This push up. I think you use the hands rather than this.
So those who are at the back, can you hear me?
Can you hear? You are able to hear this side? Audible? Yeah.
Sir, can you hear me? Okay. So this is the outline of my presentation. So first we go with the alphabets of quantum computing called qubits. Then what are quantum operations? What does entanglement mean? Then we go with actual quantum communication. That is, we talk about superdense coding. We also talk about quantum teleportation. And depending on the availability of time, we also discuss what is called quantum networks. Okay. So this is outline. So all of you must be knowing what does a row matrix mean, no? Do you remember? So what does a row matrix mean? All of you know what does a matrix mean, no? What is a row matrix? So is it a matrix? Is it a matrix? How many rows it has got? How many columns it has got? 2 columns. This is 2 by 2 matrix, no? So a matrix with only one row, that is called row matrix. Is that fine? Now tell me, is 2 by 7, is it a matrix? How many rows it has got? How many columns it has got? 3 3. 1 by 3 matrix. Only one row is that is called row matrix. Is that fine for everyone? So okay.
Use that. Up.
This side.
Yes, sir.
Okay. So what about this? Is it a row matrix? Second one. How many rows we have got? One row and 4 columns. So number of columns it doesn't matter. If there is one row, then that is called row matrix. Is it a row matrix? Only 6. How many rows it has got? One row. How many columns? Columns doesn't matter. If there is only one row, then that is called row matrix. All these 3 are examples for row matrices or not? Yes. Similarly, now can you define what is column matrix? Row matrix means only one row should be there. What does column matrix mean? Only one column should be there. Number of rows, you can have one row or more than one row. It doesn't matter. Now you see directly now. This is the general form of column matrix. How many columns it has got? How many rows it has got? The first matrix A. How many rows it has got? M rows. How many columns? One column. One column is that is called column matrix. So is it column matrix? Yes. What about this second one? Is it a column matrix? Yes. This can contain even complex numbers also. A plus IB or A plus BI form. That is also permitted elements. What about 6? Is it a column matrix? This is row matrix also, column matrix also. Why? Because it has got one row and one column. Is that okay? Now consider a coin. So coin. So maybe 1 rupee coin or 2. So if I toss a coin and if I ask when it is rotating, what is the outcome that we get? That we don't know. No? Possibilities are either heads or tails. It has not fallen on ground. You have tossed a coin, it is rotating. Now if I ask what is the outcome I get, you can only say that there may be heads probability or tails probability. So coin, there are 2 possibilities, heads or tails. Head or tail. Okay, no? Head or tail. Now coin has fallen on ground. Now with our eyes we can see that on the top, and whether we have got heads or tails we will come to know. Is that okay? So let us suppose we have got heads. Then what is the probability of getting heads in that case? What is it probability? Already I have got heads. Then what is the probability of heads? Already we have got heads. We are seeing heads. Before seeing, you can say that both are equal probability. After seeing heads, you have passed the exam. That result is known. If I ask what is the probability of passing the exam, already you cleared it. No. What is the probability? Thank you very much. 1. So now if you know that you have already got heads, now you can write in the matrix form, this is heads, this is tails. What is the probability of heads? 1. If the total probability is always 1. If the probability of heads is 1, what is the probability of tails? 0. Total probability is 1. Probability of heads is 1 means tails must be 0. No? So I can write it like this. Now it is a column matrix. It is a column matrix. Similarly, if I get tails, how do we represent this? First one is heads. This order I am fixing. First one is heads. Second one is tails. That order I am fixing. After fixing, you can tell. Now you tell me what is the probability of getting tails?
1.
Heads? 0. Now is it a column matrix again?
Yes.
Both are same or different? Different. No. One is 1 0, the other one is 0 1. Is that okay? So this matrix, instead of writing this, now my ordering is heads, comma, tails. This is the order I am following. Then this entire matrix I can simply write it as ket heads. Ket. We read it as ket. K-E-T, ket. It is heads. You know that. Is it clear? Now how to write this? Matrix form you can write it this way. What is the another way of writing according to ket notation? Ket Thank you very much. Get tails. So this is get tails, no? Is this okay? Is that okay? Okay. Now instead of this, gets heads I can say it as 0 outcome, tails I can say it as 1 outcome. 0 means my head, 1 means my tail. Name. Now this is same heads I can also write it as get 0, no? If heads I am considering it as 0 name, then get 0 also I can write, no? Then tails I am considering it as 1. This I can also write it as get 1. Is that okay? Now tell me what is get 0? What get heads? What is that matrix? Column matrix 1 0. What is get 1? Column matrix 0 1. Is it clear? This we will be using throughout lecture, throughout this FDP, everyone will be using the same notation. Get 0 means what should come to our mind? It is column matrix 1 0. What is get 1? I think this is also column matrix but 0 1. Is it clear now? Now tell me what is get 0, you only tell me? 1 0. 1 0. What is get 1? 0 1. Get 1 is 0 1. Now, what is transpose of a matrix? Rows we make it into columns, automatically we will get transposed. No? What is transpose of this matrix? Can you tell me? What is transpose of matrix 1 0? Row matrix 1 0. Thank you. Row matrix 1 0. So, transpose of this matrix is row matrix 1 0. It is like this, no? Similarly, what is transpose of this matrix? Row matrix 0 1. Row matrix 0 1. Is that okay? Now, all entries are real numbers or not? All are real numbers or not in this matrix? Is that okay? If all are real numbers, you simply take transpose of that matrix. Then whatever we get, that we call it as bra of that corresponding. Bra means row matrix, ket means column matrix. Now what is this called? This is ket 0. This is called bra 0. This is bra 0. This we read it as bra 0. This one. How did we get this? From ket 0 we got. How? By transpose. Now similarly ket 1, bra 1, how did we get? From ket 1. What did we do? Simply take transpose. Is that okay? Now this four notations, is it clear? Ket 0, ket 1, bra 0, bra 1. What is 1 0 called? 1 0 row called? Whenever I say row, bra should come to our mind. 1 0 row is called bra 0. 0 1 row is called bra 1. 1 0 column is called ket 0. 0 1 column is called ket 1. Okay. Now, can you find this product? Ket 0. Ket 0, bra 0. What is ket 0? What is ket 0? 1 0. What is bra 0? 1 0 but row matrix. Now can you multiply these two? All of you multiply the two matrices. Normal multiplication. All of you multiply and tell me what is the answer. Matrix multiplication you are familiar, no? You please multiply, and because we do lot of multiplications in our lectures. Okay, no? Matrix multiplication. What is the order of this matrix? 2 by 1, 2 rows and 1 column. What is the order of this matrix? 1 row, 2 columns. What is the order of resultant matrix? 2 by 2 matrix we get. Now you tell me what are the entries of this 2 by 2 matrix. All of you do it. What is that we do? Wow, thank you very much. 1. Matrix multiplication you remember. So this we multiply with this, then we will get 1. 1 into 0, 0. 0 into 1, 0. 0 into 0, 0. Is that okay? 1, 0, 0, 0. Is that okay? This is called get 0, draw 0 product. Similarly, we can talk about what are the other products we can calculate. Tell me. Get 0, draw 1. Get 0, draw 1. If you multiply, is this correct? You can verify, no? Is it right or wrong? Similarly, can you guess what is get 1, draw 0? What is this product? All of you calculate and tell me. What is get 1, draw 0? What is get 1? What is get 1? Column matrix 0, 1. What is draw 0? 1, 0. What is the result? Is that correct? Similarly, what is get 1, draw 1? Get 1 is what is draw 1? Multiply. What is the result? 0, 0, fourth position 1. Is that correct? Now this product multiplication is clear, and this draw and get, no, this notation is called direct notation. That is already yesterday, day before yesterday started. No, people might have explained all these things. Now all this 4. Now can you observe directly and tell me when do we get 1? See, these 4 products we calculated, we got answers. So when do we get 1? Matrix only one entry is 1, all other entries are 0. No. Only all 4 products whatever we calculated, only one position 1 is there, all other 3 positions zeros. No. So when do we, which position we get 1? This is matrix. This is 0, 1, 0, 1. This is column. This is column. This is row. This is row. Now if you see here, 0, 0 when we are calculating, that position will get 1. All other positions 0. When we are calculating 0, 1, get 0, draw 1. What is happening? Can you tell me? 0, 1 position 1, all others 0. No? Is that okay? Similarly, get 1, draw 0, which position we are getting 1? Is that now without even multiplying, now we know no. Next time we need not even multiply directly. Oh, get 1, 1 means which position 1 will be there? 4th position. Remaining all zeros. Is it clear? Okay, this notations are called direct, and this is called direct notation. This is due to this called direct. Those who are from physics background, you must be knowing about called direct, and these notations are called direct notation. So this is draw, this is get, and this is draw. Draw means you know now. This is draw and that is get. Get means column vector, draw means row vector. Draw and get, if you put it together, then that is called bracket. Draw and get, we write either this way or without this double, only with 1 we write it this way also. Is that okay? And this direct notation, it is only matrix form. If you want to write it becomes lengthy. Direct notation, you can use it in concise form, you can represent the same thing, that's all. Whether you use matrix representation or direct notation, both are for the same purpose. Only thing is, matrix if you want to write, then it becomes lengthy. 8 by 8 matrix if you want to write 8 rows and 8 columns you need to give. Instead of that, if you use direct notation, 1 line you can represent the entire thing. That is better, no? Now, Next one is, what is qubit? We know that in classical information, what is basic unit of information? Classical computing, what is the basic unit of information? 0 or 1. That is called, what is the common name for 0 or 1? Bit. In classical computing, whatever we are using, so basic unit of information is either 0 or 1, that is called bit. Similarly, in quantum information, what is basic unit of information? Quantum computing? That is called qubit. That is called qubit. Qubit stands for quantum bit. Quantum bit. Now, similar to 0, 1, here we should know how to represent qubit. What is qubit? Are you getting? This is the basic unit of quantum information. It is like ABCDs of English course, no? Alphabets of English course, like that. Basic unit of quantum information is qubit. Now we should know what does a qubit mean. What does a qubit mean? Qubit is actually represented as in this form. You know what is gate 0? What is gate 0? Tell me. What is gate 0? 1, 0. What is gate 1? 0, 1. 0, 1. Gate 0 you know, gate 1 also you know. Now, what is alpha gate 0? Alpha times 1, 0 plus beta times 0, 1. What is this? You multiply with alpha. Alpha into 1, alpha into 0, 0. This side, beta into 0, beta into 1, beta. You add these two, how much we get? Matrix addition. You are given two matrices, you add the two matrices. Respective entries we need to add. Thank you very much. No, this is not a matrix addition, no. Alpha and 0 we add, alpha plus 0. 0 and beta we add, 0 plus beta. What is alpha plus 0? Alpha. What is 0 plus beta? Beta. So finally qubit means that is also one column vector. Now qubit, whatever people say, what is that now finally you can say? That is also one column vector. Simply if I write whatever comes to my mind, that we cannot call it as a qubit. It is a column vector. Like that, for example, if I write 30, 50, can you call it as a qubit? Column vector with the two entries. Qubit is a column vector with the two entries. If I write 30, 50, can you call it as a qubit? We don't know. But for that, there is some property. Some property it has to satisfy. Some condition it has to satisfy. What is the condition? You can see the definition. What is the condition it has to satisfy? Mod alpha square plus mod beta square equals to 1. It is written now. What is the condition it has to satisfy? Where alpha, beta are complex numbers and it will satisfy this condition. Mod alpha square plus mod beta square equals to 1. Is that okay? Now you only tell me, is it a qubit or not? What is alpha value there?
30.
What is beta? 50. What is alpha square? 30 square. 30 square is 900. What is beta square? 50 square. 50 square is how much? 2500. 900 plus 2500. Is it equals to 1? No. Now you tell me, is it a qubit? No. Is it clear? So finally qubit means it is a column matrix alpha beta. What is the condition it has to satisfy? Where alpha beta are complex numbers. Okay, no, alpha beta are complex numbers. What is the additional other condition, main condition it has to satisfy? Mod alpha square plus mod beta square equals to 1. Now if I write something in the form of column matrix, can you clearly say whether is it a qubit or not? Yes. You tell me, is 1 0 a qubit or not? Is 1 0 a qubit or not? Alpha is 1. Alpha is 1, beta is 0. What is mod alpha square? 1. What is mod beta square?
0.
What is 1 plus 0? 1. Is it a qubit or not?
Yes.
Yes. Is that clear? Now tell me 0, 1, is it a qubit?
Yes.
What is alpha?
0.
What is beta?
1.
What is alpha square plus beta square?
1.
0 square plus 1 square, it is 1 no? Is it clear now? Now, okay, I'll ask you, okay. No. Even if it is wrong answer also, don't worry. At least you are attempting answer. That itself it is a great thing. Okay. Now can you give an example for qubit? No, you can tell. I will write. No need to come. Qubit means how many columns it should contain? One column. How many rows it should contain that matrix? Two rows. So now you tell me. I will write something here. One column and two rows. You give two entries. Minus 1, 0. Now you tell me, is it a qubit or not? Why?
So minus 1 was 5, 1
One.
0 was 1, 0. At 1 plus 0, 1. At a qubit, now 1 7.
Thank you very much. Now from this side, madam, first you. No, not you, madam. Second row. Now minus 1 comma 0. Can you write it something like this? Minus 1, 0 plus 0, 0. Is this correct? Is it true or false? Why? Minus 1 plus 0 is minus 1, 0 plus 0 is 0. Now, from first matrix, this matrix, I will take minus 1 outside. From first matrix, I will take minus 1 outside. Then can I write it as 1, 0? First matrix, minus 1 into 1, minus 1, minus 1 into 0, 0. Is that okay? Similarly, second matrix I take 1 outside. Now tell me what is that I need to write in place of second matrix. Second matrix I have taken 1 outside. Finally I should get 0, 0. Okay, I want to tell you, you tell me is it right or wrong. Is this correct? What is 1 into 0? 0. What is 1 into 0? 0. 0, 0 only I got no. Now what is 1, 0 here? It is minus 1 into, what is 1, 0 called? Ket 0. 1, 0 is ket 0. What is this 1? What is 0, 0, 0 is called? Instead of writing this, can you write it this way? 0 times 0, 1. Is this correct? 0 into 0, 0, 0 into 1 also 0, no? What is 0, 1 called? Ket 1, ket 1. Now, is it of the form alpha ket 0 plus beta ket 1? Oh, sorry, please. Thank you very much. You are correcting me means that is good now. So, alpha ket 0, that means you have understood. Otherwise, you wouldn't you would have kept quiet. Alpha ket 0 plus beta ket 1. So, what is alpha now? Minus 1. What is beta? 0. What is mod alpha squared plus mod beta squared? It is of this form now. Alpha ket 0 plus beta ket 1. Alpha is minus 1, beta is 0. So what is mod alpha squared plus mod beta squared? Minus 1 squared plus alpha is minus 1. Minus 1 mod minus 1 squared plus mod 0 squared. What is minus 1 squared? 1. 0 squared 0. Finally it is 1. Hence it is a qubit. Is that correct? Thank you. Okay. So that minus 1 comma 0. Is it a qubit or not finally? It is also qubit. Okay, this side. Okay. Can you give one which is not a qubit? Again, don't repeat 30, 50. Other than that, any other. Thank you very much. So it is 1, 1. Is it a qubit or not? Is it a qubit or not? No. Why? Mod 1 squared plus mod 1 squared is 2, which is not equals to 1. So this is matrix form. What is Dirac notation for 1, 1? Dirac notation means ket 0, ket 1 form it should be there. No. How to write that? Okay. So now what is Dirac notation? What is Dirac notation for 1, 1? So this 1, 1 can we write it as 1, 0 plus 0, 1 below green? My intention is somehow 1, 0, 0, 1 should come. Now this is it same as 1 into 1, 0 plus 1 into 0, 1. Is it correct? Now what is 1, 0? Get 0. What is 0, 1? Oh, but no, this is direct notation. Whether you are given like this or like this, both are same. Now you tell me what is alpha? What is beta? What is alpha square plus beta square? 2, which is not a qubit. Hence, this is not a qubit. Is it clear? Thank you. Now, is it a qubit or not? Is get 0 a qubit or not? Get 0, that is direct notation. You write matrix form for that. 1 0. Is it a qubit or not?
Yes.
Yes. Already we have discussed. No. What about get 1? Is it a qubit or not?
Yes.
Why? Not 1 0. 0 1. Mod 0 square plus mod 1 square is 1. What about this one? All of you try. Okay, you have notebooks. No, you try. 1 by root 2 get 0 plus 1 by root 2 get 1. Definition is also there. Which is simple mathematics only, no, only multiplication and matrix multiplication. That's all. What is alpha value here? 1 by root 2. What is beta value? So this is given in direct notation. Okay, alpha is 1 by root 2, beta is 1 by root 2. What is that you need to check? Mod alpha condition is given here, no. Mod alpha square plus mod beta square should be 1. That much we need to check. It is true. Is it true?
Yes, sir.
Alpha is 1 by root 2. 1 by root 2 square is 1 by 2. Beta is 1 by root 2. 1 by root 2 square is 1 by 2. 1 by 2 plus 1 by 2, it is 1. Is it clear? Now the same thing, it is given in direct notation or matrix form. You give its matrix equivalent, then you will not have confusion whether people represent using matrix or direct. You represent it using matrix form. Final answer, however we do it is one only, no sir. Only matrix form I am asking. What is matrix form for this? What is matrix form for this? Alpha, what is get 0? 1 0. Beta, what is get 1? 0 1. This entire thing alpha 0 plus this is beta 0 beta. This entire thing is same as alpha beta. Whether you give alpha beta or this, both are conveying the same thing. Is that okay? Like that. What is matrix form for this? Thank you, sir. What is matrix form for that? How to get that? It is 1 by root 2 times. What is get 0? Again same procedure. Get 0 is 1 0 plus 1 by root 2. What is get 1? 0 1. If you add, you will get 1 by root 2, 1 by root 2. Is that okay? Is that okay? That's all. Now is it a qubit or not?
Yes.
So whether you are given matrix form or direct notation, you should not have any confusion. Okay? So finally, one more example. Now you tell me, is it a qubit or not? Fourth one.
Sir.
Is not part of the rule.
We have.
Yes. Why? Alpha is 1 by root 2, beta is minus 1 by root 2. Anyhow, mod or square if you take, automatically minus goes plus. No. Is that okay? So all 4 are qubits or not? What is the matrix form of this? Fourth one? 1 by root 2 minus 1 by root 2. Thank you. Next, the complex numbers. Let us see. Fifth one you check. is it a qubit or not? Instead of real number, we have complex number. That is the only difference. Okay, this I will explain first, then you can try. Okay. If you are so if you are given complex number a plus ib or a plus bi, it's mod a plus bi square is mod a square plus mod b square. This you use. Now what is a here? 2 plus 2i by 3. 2 plus 2i by 3. Whether I is this side or that side doesn't matter, both are same. This is 2 by 3 plus 2 by 3i. What is a value? What is b value? And now you only do. Now you know what is required. You try and tell me is it a qubit or not. Is it a qubit or not? Why? What is mod 2 plus 2i by 3 square? 8 by 9. What is this square? 1 by 3 square? 1 by 9. 8 by 9 plus 1 by 9 is 9 by 9. This square is 2 plus 2i by 3 square is how much? According to our formula, mod a square. A means 2 by 3 square, mod b square, again 2 by 3 square. What is 2 by 3 square? 4 by 9, 4 by 9 equals to 8 by 9. Again for this also we need to take square law. How much we get? 1 by 9. So 8 by 9 plus 1 by 9 is 9 by 9, which is equal to 1. Hence is it a qubit or not? Yes. Now you give me its matrix representation. That's all. Simply you need to read whatever is there. Column matrix 2 plus 2i by 3. Now you next 1 by 3. That's all. Is it okay? Sixth one. Sixth one. Tell me is it a qubit or not? Same thing, only minus is there. It is a qubit. Why? Because beta is minus 2 by 3. But mod minus 2 by 3 square is again 4 by 9. No change. This is also qubit. What is the matrix form? Directly you should tell. No copying and all. Direct. 2 minus 2i by 3, 1 by 3. Column matrix. Now, okay, let me write one more. Seventh one, let us take 1 1. Is it a qubit or not? No. What is direct notation for this? Get 0 plus get 1 no? Is that okay? Now, what is 8 1? I comma 1. Is it a qubit or not? I is written as a plus ib form. What is a value? What is b value? 1. Now calculator tell me. Is it a qubit or not? Yes or no? Yes. No is correct answer. Right? This is what is the other way of writing. I times get 0 plus 1 times get 1. No? What is alpha value? Alpha is I. Beta is 1. What is mod alpha square? Mod 0 plus 1 into I square, which is nothing but 1. What is beta square? 1. Overall it is 2. Hence it is not a qubit. Now if I give a state, can you tell me whether it is qubit or not? Okay? You tell me, is it a qubit or not? Is it a qubit or not? That's why intentionally I gave this example. This is not a qubit. Why? Because qubit means it should contain only column should contain 2 entries. Here we have 4 entries. No. Condition is satisfied. Mod 0 square, mod 0 square, mod 0 square, mod 1 square is 1. But it should contain only 2 entries. But this column has 4 rows. Qubit means 1 column and 2 rows. Here it is 1 column, 4 rows. It is not a qubit. What about this? Is it a qubit? No. Now that is not allowed. That okay? Now I hope qubit definition is clear now. Here alpha and beta are called probability amplitudes. Probability amplitudes. That is the term that we use. Next question is, we have this qubit. Let us say 1 by root 3 get 0 plus square root of 2 by 3 get 1. First of all, is it a qubit or not? What is alpha square? 1 by 3. What is beta square? 2 by 3. 1 by 3 plus 2 by 3, 3 by 3, 1 correct only. So that means it is a qubit. It is a qubit. Now the question is, qubit means it is, what does it mean? It is called 0 state as well as 1 state. 0 means it is ket heads we discussed now. That means we have got heads. Ket 1 means we have got tails. It is saying you have got heads as well as tails both. That means it is linear combination of both possible states. No? This linear combination only we call it as superposition. Whenever we talk about quantum computing, people say what is superposition, what is entanglement. No, superposition means linear combination of both states. That's all. This is only called superposition state. Is that okay? Now, if I go for measurement, that means once coin falls on ground, we are seeing with our eyes now. That is called measuring. Meter is there. Meter reading we should go and see now. That is called measuring. Okay? So once if I go for measurement, what are the possibilities? I may get 0 state or I may get 1 state. 0 state or 1 state. This qubit, it is in both combinations. Once we go for measurement, out of these two only 1 state we get. Until it is measured, it is combination of both. Once you measure, then quantum nature will go. Only classical will come. Are you getting? So a state is going to be in quantum, okay, no, until it is measured. Once you go for measurement, quantum nature is gone. Only classical will remain. Are you following? That means this is qubit. If I go for measurement, either I will get 0 value or 1 value. 0 or 1 means again it is classical or not? Are you getting any confusion? Classical. Okay. Even if you have not understood this, okay, I will explain in another way. Now if I go for measurement, at least understand that there are 2 possible answers. One is 0 answer, the other one is 1 answer. Next, what is the probability of getting 0 as answer? Is the question clear? 1 by?
1 by 2.
0.
No. What is the coefficient of get 0? 1 by root 3. This square is the probability. 1 by 3. If I go for measurement, probability of getting 0 is mod 1 by root 3 square. That is 1 by 3. What is the probability of getting 1? Root 2 by 3 whole square. That is 2 by 3. What is total probability? 1. 1 by 3 plus 2 by 3, it is 1 only. Are you getting? That's why this condition. What is this alpha square? Get to 0. What is the probability of getting 0? What is this beta square? What is the probability of getting this 1? Is it clear? Both if I add, it should be always total probability is 1, no? Is that clear? Okay, now you tell me, if I measure this, what is the probability of getting 0? 1 by 2. What is the probability of getting 1? 1 by 2. 0 and 1 we are getting with same probability. Then that is called equal superposition state. Both states I get with the same probability, like tossing a coin. Heads and tails with 1 by 2 probability we get, no? Is that okay? Now in this case, what is the probability of getting 0? What is the probability of getting 1? 1 by 2. In this case, what is the probability of getting 0? 8 by 9. 8 by 9. 2 plus 2i by 2 whole square we have already calculated. 8 by 9. What is the probability of getting 1? 1 by 9. In this case, what is the probability of getting 0? 8 by 9. That is also same. 1? Now you should answer for this. If I measure this state, what is the probability of getting 0? What is the probability of getting 1? First you write alpha ket 0 plus beta ket 1 form. All of you write that. Ket 0 you write alpha ket 0 plus beta ket 1 form in that form. Please do it. Okay, now? Already answer is there, no? Sir, are you able to get something like that? See, ket 0 means 1 0. Ket 0 means 1 0. Ket 0 is 1 0. Okay? Now 1 0 I can write it as 1 0 plus 0 1. Both are same or not? 1 0 plus 0 into 0 1. 0 into 0 1 is 0 0. Now 1 0 is ket 0. 0 1 is ket 1. Finally 1 0 ket 0 I have written it as 1 into ket 0 plus 0 into ket 1. Is that correct or not? You tell me. Correct or not? Both are same, no? That means it is correct. Now you tell me what is alpha value? 1. What is the probability of getting 0? It is nothing but mod alpha square. What is mod alpha square? 1 square. 1. If 1 I am getting with the probability 1 means other one must be with the probability 0. What is beta square? 0 square 0. Correct only, no? Oh, is that clear? Get 0 state, if I go for measurement, with the probability 1 we get 0. With the probability 0 we get 1. Same thing can you do for this? Get 1. All of you write ket 1 in alpha ket 0 plus beta ket 1 form. Any answers? Okay, I will randomly ask. Okay, have you done? Okay, what about another last bench, last row, middle? Have you completed? Okay, those who are complete. Okay, what is difficulty? Okay, I just erase this and write quickly. So what is given to us? What is Ket1? Ket1 is 0, 1. Is that okay? Now can we write this as 0 in 0, 0 plus 0, 1. Do you agree? 0, 1 is same as 0, 0 plus 0, 1. Is that correct or not? Our intention is Ket 0 and Ket 1 we should bring in. That is our goal. Now, this 0, 0, can we write it as 0 times 1, 0? Is that correct or not? 0, 0 is 0 times 1, 0. Is that correct or not? Correct. Now 0, 1 as it is I write. 0, 1 is it same as 1 times 0, 1? 1 into 0 is 0. 1 into 1 is 1, 0, 1. Here 0 into 1 is 0. 0 into 0 is 0. You may ask, why are you writing like this? What is the general form? Alpha Ket 0 Ket 0 means it is 1, 0, no? 1, 0, Ket 1 means 0, 1. Somehow I should bring in both. I am writing it in terms of Ket 0 and Ket 1. That's all. Now you tell me, what is alpha value? This is 0 times Ket 0. 1 times, what is this? 0, 1 is called what? Ket 1. Now what is alpha value? 0. What is beta? 1. Is that okay? Now you tell me, what is the probability of getting 0? We are given Ket 1 state. What is the, when I go for measurement, we get either 0 state or 1 state. What is the probability of getting 0 state? It is given by mod alpha square. What is alpha value? 0. What is mod alpha square? Mod 0 square. That means it is 0. What is the probability of getting 1 state? Mod 1 square. That is 1. Total probability is 1. No, 0 plus 1, 1. Correct only. Simply only 1. Qubit general form is alpha Ket 0 plus beta Ket 1. That means it is in combination of 0 state and 1 state. Once we go for measurement, out of the two only one we get. When coin we rotate, when it is in the sky, it is both heads and tails both. Once it falls on ground, two captains are going to see whether heads or tails. Once it falls on ground, both states if they see, then problem no. Who is winner? We don't know. So only one state we get. Don't assume that it stands like that, just like that. Then gone. One captain will see this side, one captain will see that side. Then both says that both have won that task. Both want batting only. Then not possible. Is that okay? Are you getting or not getting? Now finally, when we go for measurement, we get 0 state or 1 state. What is the probability of getting 0? Mod alpha square. What is the probability of getting 1? Mod beta square. So one last question on this. You are given a state 1 by root 4 root 2 again 1 by root 2. What is the probability of getting 0? 1 by 2. What is probability of getting 1? 1 by 2. What is Dirac notation for that? Already we discussed the same example. What is Dirac notation for that? Answer is also there on the screen. Okay, no. 1 by root 2, 1 by root 2. I have given it in the matrix form. Now I am asking you to convert it to. Okay, all of you please convert into Dirac notation. Thank you. Thank you. 1 by root 2 Ket 0 plus 1 by root 2 Ket 1, which is nothing but third one, no? Third one only, no? That's why I said answer is there. Okay. Now is it clear what is called measurement? What is qubit? What is general form of qubit? Alpha Ket 0 plus beta Ket 1. Then you need to say what is the condition also. What are the conditions it has to satisfy? Mod alpha square plus mod beta square is 1. Okay. Now alpha Ket 0 plus beta Ket 1, if I go for measurement, what is the probability of getting 0 state? mod alpha square. What is the probability of getting one state? Mod beta square. Is it clear now? Only two things we have discussed so far. One is definition of qubit, the other one is measurement of qubit. In the process, I also mentioned what is called superposition. Superposition means linear combination of both states. Is that okay? Now, next, we need to understand another concept called tensor product. Okay, tensor product, like matrix multiplication. No, here also it is some stuff. I'll explain with example. It will be here. Okay, you are given two matrices like this. Both are column vectors. No? How to find tensor product of these two vectors? Actually, are they quantum states or not? Is it a qubit or not? That we don't know. If they clearly say that mod a square plus mod b square is 1, then it is a qubit. Similarly, other side, mod c square plus mod d square is 1, then it is qubit. Now, how to find tensor product of these two matrices or two quantum states? Simple. Tensor product, it is denoted by ket phi tensor. This is tensor product symbol. Okay? Ket psi. This is pi, this is psi. Okay? Equals to, first you write the first matrix. This is first matrix. No, A, B, you write as it is. A, B. As it is, you have written. Next, what is that you can do is, next to each element of first matrix. This is first matrix one element. You copy second matrix as it is. CD, here also you copy CD. Is that okay? What is that we have done? First matrix as it is you have taken. Against each element of first matrix, you copied second matrix, entire matrix as it is. Is that okay? Now, you multiply respect to A and C, you multiply. A, C. That A and D, this is below that row, next row you put. Next, this is below that row, B, C. This is below that, B, D. This is only tensor product of these two. Is that okay? Okay, now I will take one example and do it. Example 1, 2, 3, 4. What is tensor product? You please calculate. Instead of A, 1 is there, B, 2 is there. All of you calculate tensor product of 1, 2, 3, 4. Huh? 3, 4, 6, 8. That's all. What is tensor product? 6, 8. So 1, 2 as it is we copy. What is the next thing that we do? Again is 3, 4, 5. That is 3, 4. This is 3, 4. So it is what? 1 into 3, 3, 1 into 4, 4, 2 into 3, 6, 2 into 4, 8. That's all. This is only tensor product. Is that okay? Is this correct? That example, whatever is shown. Numerical example. One by 4, 3 by 4, 2 by 3, 1 by 3. Okay, na? All of you do this. I don't explain, you only do. If you are not able to do, again I will elaborate. Same procedure you follow, dicto. Yeah. Final result you tell me. Final matrix you tell me. V1 V1 W1, V1 W2, V1 W3. Next to V2 W1, V2 W2, V2 W3. That's all. See first matrix, second matrix. You see here. First element, second matrix arity is copied. Second element, second matrix arity is copied. After that, now is that okay? Clear? Okay. Now third example you do it. Directly can you tell me what is the answer for this? General example. Alpha 1, beta 1, alpha 1, beta 2, and so on. Alpha 1, beta k. After that, alpha 2, beta 1, alpha 2, beta 2, and so on. Alpha 2, beta k, and so on. Last, alpha n rectangular. You have understood. Is that okay? Is that okay? Now instead of one by one matrix, okay, you do this. Now I don't explain. You know what is ket 0. You also know what is both are ket 0. So enough. Ket 0 is 1 0. Both sides 1 0 only. Now you can find that product now. How many 3 zeros? 1 3 zeros. Correct? No. Why? What is ket 0? It is 1 0. Tensor product 1 0. Is that okay? So now what is that we need to do? First matrix you write as it is. Again is each entry, second matrix you copy. 1 0, here 1 0. Now what is 1 into 1? 1. 1 into 0? 0. 0 into 1? 0. 0. 0 into 0? 0. That's all. Now this is ket 0 tensor ket 0. Some people they also write this as like this. By removing this symbol, they also write it like this. Sometimes textbooks. Okay? Sometimes they also write this like this also. You should not have any confusion. All are same. Whether we write ket 0 tensor ket 0 explicitly with the tensor symbol, or without tensor ket 0 ket 0, or without two kets, only one ket 0 0. All are conveying the same meaning. The matrix is 1 0 0. Is that okay? Now you do for what is ket 0 tensor ket 1. Next, all these three you do. Ket 1 tensor ket 0. Next, ket 1 tensor ket 1. Because all these four we will be using when we talk about operations. Okay? All these four you please do. Second one you complete first. That's all. 0 1 0 0. Is it okay now? Directly shall I write? What is another way of writing this? What is another way of writing this? 0. Simply 0 1. What is another way of writing this? Ket 0 1. Is that okay? Now what is 1 ket 1 tensor ket 0? 0 0 1 0. Very good. 0 0 1 0. What is another way of writing? Ket 1 ket 0. Another way of writing? So finally what is this? 0 0 0 1. What is another way of writing? Ket 1 ket 1. Another way? Is that okay? So now if you see here, 0 0 means first position 1. 0 1 means second position 1. 1 0 means third position 1. 1 1 fourth position 1. Now are they qubits? No. Now you can understand. Is it a qubit? 0 qubit or not? Now total how many qubits are there in this? 2 only, no. This is 1 qubit, this is another 2. Total, it represents 2 qubits, not 1 qubit. Is that clear? Rule is same. Again, it represents 2 qubits. What is the condition it has to satisfy? All elements square you take and sum, it should be 1. Mod 1 square plus mod 0 square plus mod 0 square plus mod 0 square. 1 is it coming? It is correct. But it represents how many qubits? 2 qubits. What about this one? How many qubits it represents? 2. What are they? 1 qubit is 0, 1 qubit is 1. Here it represents how many qubits? 2. First qubit is 1. Second qubit is 0. This also represents 2 qubits. First qubit is 1. Second qubit is also 1. Is that clear? Okay. Get 0, 1. This also we calculated. No? What is the answer? Is that okay? So all these things we completed. 0, 1. 1, 1. This also we completed. No? Is this okay? Okay. Okay. Anyhow, up to this we have break for some time. Then I will continue.
You have an opportunity to interact with me. He will not come in between. Now you cooperate. Okay? Alright? Those they wanted to talk to him. Okay?
Okay, we will continue with the tensor product. So, can you determine what is tensor product of 1, ket 1, tensor ket 0, tensor ket 1? We have done for 2. Now it is 3 matrices. What is ket 1 tensor ket 0? Ket 1 is 0, 1. Ket 0 is 1, 0. Tensor product it is 0, 0, 1, 0. Now you can write you can write ket 1 tensor ket 0. This is times to ket 1. So first you can calculate this part. Whatever result you get, you can apply tensor ket 1. Now we have already calculated ket 1 tensor ket 0. What is the answer? What is the answer? What is ket 1 tensor ket 0? Second term. 0, 0, 1, 0. Tensor. What is ket 1? What is ket 1? 0, 1. Can you please complete now? Can you tell me what is the answer? Open your notebook. Four zeros. 4, 0, 1. Remaining zeros. Correct. 4, 0, 1 or 5 zeros 1. First 0 into 0. 0. This is 0 into this 0. 0 into 1. 0. Next this 0 into 0. Remember now? Or do you want me to write almost straight? It is 0, 0, 1, 0. Against each element 0, 1, 0, 1, 0, 1, 0, 1. Now you can multiply now. Now you tell me what is the answer? 0, 0, 0, 1, 0, 0. Is this correct? Is it a qubit? No, it is not. A qubit means because 8 entries are there, it is definitely not qubit. How many qubits are there in this? This is 1 is 1 qubit, this is another qubit. It is a 3 qubit state. We talk about 1 qubit, 2 qubit, this is 3 qubit state. Is that okay? What is another way of writing this? We can simply write it as ket 0, sorry, ket 1, ket 0, ket 1 without tensor symbol. Or we can also write it as ket 1, 0, 1. Is that okay? Okay, now can you find out this value? What is ket 1 tensor, ket 1 tensor, ket 1? Ket 1 tensor, ket 1 tensor, ket 1. First two you do, remaining after getting the answer that you do with the third one. How many zeros? 7 zeros, 1. Okay, correct. All should get the same answer. It is 0, 0, 0, 0, 0, 0, 0, 1. All of you got the same answer? Yes. Okay. So procedure is same. Now you can calculate for anything, no? Next one is, we talk about independence of systems by using tensor product. Okay, so we'll go with the first example, then we'll come back to this. Now you are given a state like this. Here, we are given a state like this. This is a quantum state. You write matrix form of this. Now you know what is ket 0, 0 meaning, no? What is the matrix for that? Do you remember? What is ket 0, 0 matrix? 1, 0, 0. Okay, first write down matrices for ket 0, 0, ket 0, 1, ket 1, 0, ket 1, 1, all 4.
Look at the book. He is writing that.
Okay. Whether you got the same answers, you check, cross verify. That is final answer. Already we have completed that. You got the same answer or not? That okay? So that all of you got the same. Now you convert this into matrix form. What is ket pi? 1 by 2 times. What is ket 0, 0? 1 4 zeros or 1 3 zeros plus I by 2 times. What is ket 0, 1? 0 1 0 0. You please complete it now. What is ket 1 0? 0 1 0 minus I by 2 times. What is ket 1 1? Is that okay? Now it is, what is 1 by 2 into this? 1 by 2 0 0. 0, 0, minus 1 by 2, 0. Is that correct? Minus 1 by 2 I multiplied 0, 0, minus 1 by 2, 0. Is that okay? Now tell me what is last entry? 0, 0, 0. You add all these 4 and tell me what is the answer? Instead of direct notation, if it is matrix form, for us it is easy, no? What is addition of all these 4 matrices after adding? No. What is the first entry? 1 by 2 plus 0 plus 0 plus 0. Correct, no? 1 by 2. What is second entry? 0 I by 0 plus this 0 plus this I by 2 plus this 0 plus this 0. How much? I by 2. What is third entry? Minus 1 by 2. What is fourth entry? Minus I by 2. Now the question is it possible to write this matrix a tensor product of 2 different matrices? Is the question clear? We are given this matrix. Is it possible to write it as tensor product of 2 qubits? This is a 2 qubit state or not? 1 qubit state? 2 qubit state. That means, is it possible to write it as first 2 qubit tensor product second qubit? Is it possible to write it this way or not? If possible means, then you should tell me what is first matrix, what is second matrix, no? Are you okay? 1 by 2, I by 2, minus 1 by 2, minus I by 2, no? Now, what is that we got? 1 by 2, 1 by 2, I by 2, minus 1 by 2, minus I by 2. Is it same as what is direct notation? This is direct notation. What is matrix form of this? 1 by root 2. What is matrix form of this? Minus 1 by root 2. Matrix form this we discussed also, no? What is matrix form of this? 1 by root 2. 1 by root 2, I by root 2. Now you check, is it true or not? Is it true or not, you check. All of you do it. Whether if both are same, then we got the answer. That is the meaning. Okay, any answer? Whether you were able to get the same thing? Yes. That means what? This 2 qubit state, this is actually 2 qubit state, no. This 2 qubit state, I am able to write it as tensor product of first qubit state and second qubit state. If at all we are able to write it this way, then we say that this combines first qubit state, let us call it as system X, this is system Y. These two systems are independent, there is no relation between them. So you are given 2 qubit state system. Now that is combination of 2 qubits means I need 2 different qubits, no? Qubit 1, qubit 2. Qubit 1 is coming from system X. Qubit 2 is coming from system Y. Okay? If I can write combined state as first qubit system state, tensor product, second qubit system state, then we say that the two systems, namesake, they are together. Still they are different. That is called independent. Now, this system, the corresponding systems are independent. When do you say that a state is independent? State, when you can write it as tensor product of individual system states. Are we able to write it here? No. One state is given, 2 qubit system state is given. Are we able to write it as first qubit state, tensor product, second qubit state? Are we able to write it or not? Yes. Then we say that they are independent. If you are not able to say, then we cannot say that they are independent. There is some kind of relation between the two. Is that okay? Or another way is, what is the coefficient of 0, 0? Is it this value into this value? What is the coefficient of get 0, 0? Get 0 coefficient here, get 0 coefficient here, you multiply that. Is it same? See, this is given to us. What is coefficient of this? What is coefficient of this? It is clear now. What is coefficient of 0, 0? 1 by 2. How did we get that 1 by 2? Can you say that this is 1 by root 2 into 1 by root 2? Is that correct? 1 by root 2 into 1 by root 2, is it 1 by 2? Now tell me what is coefficient of 0, 1? First one 0 you take. What is 0 coefficient is 1 by root 2. Second one 1 you take. I by root 2. 1 by root 2 into I by root 2. Is it same as I by 2? Similarly, what is 1, 0 coefficient? First one you take 1 coefficient. That is what? Minus 1 by root 2. Second one 0. 0 is 1 by root 2. It is minus 1 by 2. Correct? Last one 1, 1. Here also 1, here also 1. 1 is minus 1 by root 2. Here it is I by root 2. It is minus I by root 2. Is that okay? That is also matching. Then we say that the systems are independent. We have put them together, but still they are behaving independently. There is no relation between one and the other one. Then we say that the systems are independent. Now I will show you this definition. See, probability of x comma y equal to a b is same as probability of x equal to a, x, y equals to b. That's what we discussed now. Then we say that the systems are independent. Is that okay? I will show you another example where now are the systems independent or not? Now you check. Are they independent or not? So what is the matrix form of this? What is matrix form? What is matrix form? What is get pi? 1 by root 2. What is get 0, 0? 1 triple 0. 1 by root 2. What is get 1, 1? If you add, what is that 1 by root 2? Triple 0 plus 0, 0, 0, 1 by root 2, which is same as is that correct? Now the question is what? Is it possible to write it as tensor product of 2 qubits? Yes means then you should tell me what are the qubits. Okay, you give me answer. 1 by root 2 0. Is it a qubit or not? Mod alpha square plus mod beta square is 1. Mod alpha square is 1 by 2. Mod beta square is 0. It is not at all a qubit. Is it a qubit or not? Not a qubit. You should give 2 qubits now. You try any other answer? Is the question clear? We need to write it as tensor product of 2 qubits. 2 entries here, 2 entries here. You tell me what are that 4 entries. Then over. Any answer? See, many of you are trying but you are not able to get answer. But actual answer is it is not possible. That's why you are not able to get. That will show why it is not possible. Why it is not possible. Let us take this is A state, this is AB. If at all it is possible, let us take this is CD. AB value we don't know, CD values we don't know. What is tensor? This value must be equal to what? What is tensor product of ABCD? AC, AD, BC, BD. Now, respective terms are equal, no? Now, AD is equal to 0 or not? AD is 0. When does AD become 0? You are multiplying 2 numbers, that should become 0. When does it become 0? If I multiply 2 positive numbers, whether I will get a 0. If I become 2 non-zero numbers, whether we will get a 0. Thank you very much. Any one number must be 0. Let us assume that A is 0. A equals to 0. One possibility is A equals to 0. If A equals to 0, what should happen here? AC equals to 1 by root 2, no? Because AC should become 1 by root 2 or not? That becomes wrong. If A equal to 0, AC never becomes 1 by root 2, no? A is 0. 0 into whatever C is there. 0 into something is 0. But we should get 1 by root 2. It is not possible. Similarly, what is the other? That means A equal to 0 is wrong answer. What is the other option we have? D equals to 0. D equals to 0. This may be one possibility. If D equals to 0, what should BD should be 1 by 2 according to this? BD should be 1 by 2. If D equal to 0, BD becomes 1 by 2. Is it possible? Not possible. It is impossible actually. That's why it is impossible we are showing, no. However you try, it is impossible to write it as tensor product of 2 qubits. Then we say that they are very much related. They are how? One qubit is here, another qubit is in say London. One qubit is here, another qubit in London. But still they are related. You have physically separated them, but still there is some kind of relation between them. If you do something here, automatically some changes will happen there. You might have seen, no. For example, people used to say that twins both are say baby girls. One girl is in Chennai, another girl is in London. Parents, one is with the grandparents, one is with the parents. Now if this girl smiles, same time, all of a sudden, same time that girl who is in London also smiles. Distance is more. They are very much separated. Okay. But still, if something happens here, all of a sudden some changes is happening there. You might have heard people saying like this. Are you getting that? Though we separate, but still they share some kind of relationship. That kind of relationship, we say that if some changes happen in one, automatically changes happen in other. Not only in Chennai, London. You take one is in Chennai, the other one is Mars planet, different. According to Elon Musk, SpaceX mission is successful. Maybe after a few years, people may go like Chennai to Delhi tour, Chennai to Mars planet. Those who are able to go, they will go now. Now itself people are going. After 10 years, definitely many will go. That time still one cries here, other one who is on Mars also cries. That means even if you separate them, there is some kind of relation between the two. Then we say that the two are not independent, they are entangled each other. And this state is called entangled state. And it is starting point, it is the first step in many different protocols, including the protocols which we are going to discuss. Is that okay? That is called entangled state. Is it entangled state or not? Yes. Why? Entangled state means it is impossible to write it as tensor product. Is it clear? If we are able to write it as tensor product, then it is called independent state. Thank you. It is called independent state. Not only this, there are many states. Okay? You might have heard already. Here it is not possible to write it this way. All these states are entangled states. They are known as Bell states. This state also it is impossible to write it as tensor product. This state also, all these states they are called Bell states. They are entangled states. Now, two main properties or principles of quantum mechanics. One is superposition is clear. Superposition means linear combination of both states. Entanglement. Whoever talks about quantum computing, two main things they talk about is superposition and entanglement. Now, entanglement is it formally clear mathematically? Is that okay? Entanglement means that states we are not able to separate. Is that okay? These are 4 examples. Okay, no? 4 examples. Next. Now, so far, what is that we have discussed? What is qubit? What does measurement mean? What is tensor product? With the help of that, we also talked about what is independence and entanglement. These are the things we discussed so far. Now is how to represent quantum operations. Any quantum operation, it is represented by a matrix. Not any matrix, that matrix should satisfy some property. Is that okay? Any quantum operation, what are logical operations? Different logical operations. Classical computing, we have different operations. No, what are they? And classical AND operation, we have OR operation, logical. NAND operation, NOR operation, like this we have different operations. No? Here also we have different operations. But all quantum operations we represent using matrix, that's all. Any quantum operation you say, simply there is one matrix. We should know what is that matrix. If matrix is different, they give different name to that. Is that fine? Is that clear? Now, what is transpose of a matrix? Conjugate transpose of a matrix. You know what is, can you write what is transpose of this matrix? What is B transpose? What is B transpose? Row you make it into column. 1 plus I, 2 minus I. This is second row. 3 plus 2I, 4. This is called transpose. Then what is conjugate transpose? This part we have completed. What is conjugate means? What is conjugate of A plus IB? A minus IB is complex conjugate. What is conjugate of 3 plus 2I? 3 minus 2I. What is conjugate of 8? 8 can be written as 8 plus I into 0. 0 into I is 0. It is 8. What is conjugate transpose? 8 minus I into 0, which is 7 and 8. If there is no imaginary part, conjugate transpose is same thing only. Now Now you tell me what is conjugate? This is denoted by B dagger. B dagger. So you take conjugate of which element? What is conjugate of 1 plus I?
1 minus I.
What is conjugate of 3 plus 2I?
3 minus 2I.
What is conjugate of 2 minus I?
2 plus I.
What is conjugate of 4?
1 minus I is 0.
This is called conjugate transpose or Hermitian transpose. Is that okay? Is it clear what is conjugate transpose? If I give you a matrix, can you find conjugate transpose? Yes. Now, if this is conjugate transpose of this matrix, is that okay? Correct or not? Now, all quantum operations are represented by special matrices. That's what I mentioned now. Called unitary matrices. Any quantum operation, there is one matrix for that. But that matrix should satisfy some condition. What is the condition? U is a matrix. U times U conjugate transpose equals to U conjugate transpose times U equals to identity matrix. Then we say that that matrix U represents one valid quantum operation. Is that point clear? Finally, quantum operations are represented by matrices. Any matrix 1, 2, 3, 4 if you write, that may not be quantum operation. For that, what is the condition it has to satisfy? What is the condition it has to satisfy? It is written there, no. What is the condition it has to satisfy? U times U dagger. What is U dagger? Conjugate transpose equals to U dagger times U equals to identity. Now you tell me U1001 is the matrix. You write conjugate transpose of 1001. What is conjugate transpose? What is transpose of 1001? What is transpose of 1001? This is U. You write what is U transpose? Again same thing we get now. What is U dagger? Conjugate transpose. What is conjugate of 1? 0. Again same thing we get. What is the next condition we need to check? U times U dagger. What is U? 1001. What is U dagger? If I multiply, then what is that I need to get? This is identity or not? Hence, it represents valid quantum operation. 1001 is a valid quantum operation. Not only 1001, even this also represents one valid quantum operation. Even this also represents one valid quantum operation. This also represents one valid quantum operation. This matrices you must have seen yesterday's and previous lectures. Some of these matrices you must have seen. This operation is called quantum X operation or quantum not operation. X operation. This is called quantum Z operation. Z gate. This is called Hermite operation. Definitely you must have seen this. Okay. At least these things we discussed. Is that okay? All quantum operations are represented by what? Unitary matrices. What is unitary matrix? A square matrix is said to be unitary if U times U dagger equals to U dagger times U equals to identity. Then it represents one valid quantum operation. There are in fact so many unitary matrices, that means they are all valid quantum operations. Is that okay? Now why this is 2 by 2? Qubit means only two possible states, no. That's why all these matrices they require only one qubit as input. NOT gate requires how many bits as input? 1 bit. Now AND gate 2 bits. OR gate 2 bits. Like that, all these operations, these are 2 by 2 matrices. So they require one qubit as input. They are called single qubit operations. NOT gate is single bit operation. Like that, these are single qubit. Bit means here it is qubit. Single qubit operations. Is that okay? Now we discuss one by one in detail. Similar to NOT gate classically NOT gate what does it do? NOT gate what does it do? What is NOT gate? Classical NOT gate. If I give 0 as an input, what is the output I get? 1. If I give 1 as input, 0. Similar to that, here also we have quantum NOT gate. What happens? Quantum gate means quantum state qubit is input. If I give ket 0 as input, it becomes ket 1. If I give ket 1 as input, it becomes ket 0. That's all. Same, where 0 becomes 1, 1 becomes 0. Here ket 0 becomes ket 1, ket 1 becomes ket 0. And that gate is called quantum X gate or quantum NOT gate or poly X gate. Okay? It is quantum equivalent of classical which gate? Classical NOT gate. Thank you. Classical NOT. It flips the state of qubit from 0 to what? Ket 0 to ket 1. Ket 1 to ket 0. Is that correct? This is the matrix for that. Any quantum operation, what did I say? It is represented by a matrix. This is the matrix for that. Okay? Now, how to represent it using circuit diagram? Like NOT gate as circuit, AND gate as circuit, OR gate as circuit, XOR gate as circuit, NAND like that. No, here also we represent like this. This is input. This is input qubit. This is the gate name in box. And after applying this, whatever output you get, that is the output here. Is that okay? Is the notation clear? Now, 0, ket 0 is input. Then we will get something as output here. This output is again quantum state or not? Quantum gate means input is quantum, output is also quantum, no? But if you want classical quantum, you cannot do anything with that information. If you want to get some information from that, you need to go for measurement. That's what I said, no. Once we go for measurement, then only we will get classical outcome. This symbol is measurement symbol. This is measurement symbol, meter symbol. Meter means for reading, no measurement. Is that okay? Here it is quantum. Here it is classical. Similarly, ket 1 also same thing. Correct, no? Now you tell me what is the output here? What is the output we get here? What should we do? Input is ket 0. Which gate we are applying? NOT gate, that is X gate. Quantum NOT gate or quantum X gate. So how to do that? So X gate I am applying to the input ket 0. Is that okay? Now you write, what is X gate? What is X gate? It is nothing but one matrix. No, what is that matrix? Here only it is displayed. No. 0, 1, 1, 0. X is nothing but 0, 1, 1, 0. What is ket 0? 1, 0. Now if you multiply, what is that we get?
0, 1.
Matrix multiplication you should never forget. Okay. What is the answer we get?
0, 1.
This is normal multiplication. Matrix multiplication.
0, 0, 1.
You get 0, 1. See, 0 into 1, 0 plus 1 into 0, 0. That is first row. 1 into 1 plus 0 into 0. That is second row. Normal matrix multiplication. Okay, if you have forgotten, you please try to revise that. Okay. Matrix multiplication will get 0, 1. Okay. What is 0, 1? Get 1. Cat no, that's what I said no. Cat 0 it changes to cat 1. Similarly, cat 1 is given input. What is that we get? You do it and check whether are you getting cat 0 or not. What is that you need to do now? This entire thing we have done now. Now we have got cat 1. What is the probability of getting 0 now? If I go for measurement, here it is cat 1. If I go for measurement, I may get 0 state or 1 state. State 0 or state 1. 0 state or 1 state. What is the probability of getting 0? Already this we discussed no. Cat 1 can be written as 0 into cat 0 plus 1 into cat 1. This already we have discussed. If I go for measurement, what is the probability of getting 0? This coefficient square mod 0 square, it is 0. What is the probability of getting this state? It is 1. Now tell me what is the probability of getting 0 here? 0. What is the probability of getting 1? 1. Now tell me measurement gives us classical state 0 with how much probability? Cat 1 is 0 into cat 0 plus 1 into cat 1. If I go for measurement, what is the probability of getting 0? 0. 1. Okay, na? Probability of getting 0 is 0. Probability of getting 1 is 1. Is that okay? Now you do for this. What is the answer we get? What is the state here? You tell me. Same procedure you follow. Okay, same procedure. X plus you write what? This is x on cat 1 no? What is x value?
1, 0, 0.
0, 1, 1, 0. What is cat 1? 0, 1, 0. You multiply both. Column matrix 1, 0. Right. Column matrix 1, 0. Which is nothing but cat 0. Now what is the state here? Cat 0. So cat 0 we can write it as 1 into cat 0 plus 0 into cat 1. Is that correct? If I go for measurement, what is the probability of getting 0? 1. What is the probability of getting 1? 0. Is it clear? X on cat 1. You can see no? What is the probability of getting 0? 0. What is the probability of getting 1? 1. Sorry. This one, what is the probability of getting 0? 1. 1 is 0. Any doubt in this exegete? Exegete, finally what happens? Cat 0 becomes cat 1, cat 1 becomes cat 0. Exegete, what is input?
0, 1.
What is input for exegete? Exegate is single qubit gate. What is input for exegate? Qubit. 1 qubit is input. we have discussed with ket 0, ket 1. Not only ket 0, ket 1 are qubits, or any other qubits are possible. See, X gate what is input? Qubit. Any qubit is input. But we have discussed only ket 0 as input, ket 1 as input. Any other qubits are possible or not? Possible. Infinite number of qubits are possible. Now, can you give any other qubit other than ket 0, ket 1? Can you give an example for qubit other than ket 0, ket 1? Sir? 1 by root 2, 1 by root 2. Okay? So 1 by root 2, 1 by root 2 is a qubit or not? What is this? This is 1 by root 2 ket 0 plus 1 by root 2 ket 1. Already we have discussed this now. This is a qubit. This is a qubit. Now you tell me what happens instead of this, I will give 1 by root 2 ket 0 plus 1 by root 2 ket 1 as input. What is the state I get here? Is the question clear? X gate, I am giving 1 by root 2 ket 0 plus 1 by root 2 ket 1 as input. Then what happens? By linearity, which is same as 1 by root 2 X gate on ket 0 plus again 1 by root 2 X gate on ket 1. Linearity. X gate I apply to both qubits separately. What is X gate on ket 0? Ket 1. What is X gate on ket 1?
Ket 0.
Ket 0. Now we can write this as 1 by root 2 times ket 1 plus 1 by root 2 times ket 0. That's all. Now what happened? Coefficients are swapped. No. Coefficients are swapped. That's all. Are you not only ket 0, ket 1 as input, you can give any quantum state as a qubit as input. Any qubit as input. Now, if 1 by root 3 ket 0 plus square root of 2 by root 3 ket 1 is input. X gate I am applying. What is the state here? Can you tell me? That's all. What is answer? What is answer for this? Are you getting that? Same procedure will follow. X on 1 by root 3 ket 0 plus 2 square root of 2 by 3 ket 1. Is that okay? It is 1 by root 3 times x on ket 0 plus I am applying x individually. X on ket 1. What is x on ket 0? Ket 1 plus square root of 2 by 3. What is x on ket 1? Ket 0. What? That is answer. What happened? Simply coefficients are changed. No. They are swapped. If we apply x gate to any qubit, arbitrary qubit, not only ket 0, ket 1 are inputs. So many inputs are possible. Any qubit is input to x gate. In case of classical NOT gate, only 0, 1 are bits. No other bits are possible. But quantum qubit means not only 0, 1. Many are possible in between. No. Infinite number of options are there. Okay? That is X gate. Similarly, we can talk about Z gate. Again, what should come to your mind? It is represented by what? Any quantum operation is represented by what? Unitary matrix. That means one matrix I should give for this again. represented by matrices. What type of matrices? Unitary matrices. Is that okay? For this there may be some different matrix. That's all. No, same procedure. Matrix is different. Other name is poly. These are due to poly, so they are called poly jet gate. Poly jet gate. What does it do? What does this gate do? If you give ket 0, okay, you only calculate and tell me what is. Now I have not explained anything, but still you should be able to calculate. What is Z on ket 0? What is Z on ket 0? You please calculate. How to represent this? This is Z gate. This is ket 0. Correct? In place of X, Z is there. That's all. What is Z on ket 0? Same procedure you follow. What is Z matrix? What is Z matrix? What is Z unitary matrix? 1 0 0 minus 1. Is that okay? What is ket 0? 1 0. Now you tell me what happens. Normal multiplication.
1 0 0 minus 1.
See, this is 2 by 2 matrix, no? This is 2 by 1 matrix. If I multiply it, then result will be 2 by 1 matrix, no? Column matrix 1 0. This is normal matrix multiplication. Normal matrix multiplication. Column matrix 1 0. What is 1 0? Which is same ket 0. Oh, that means what is that? Ket 0 is input. Output is also ket 0 only. This gate. But X gate, ket 0 is input. What is output? Ket 1. But this gate, ket 0 is input. Ket 0 only output. Now try for ket 1. What is X on ket 1? Sorry, Z on ket 1. I will try this. What is Z matrix?
1 0 0 minus
1 0 0 minus 1. What is ket 1?
0 1.
0 1. Column matrix 0 minus 1. Why you are getting confused with the normal matrix multiplication? What is that we do? This row we will multiply with this column. Respective elements. 1 into 0, 0 plus 0 into 1, 0. That means first element is 0. Next 0 into 0, minus 1 into 1, 0 plus minus 1. Is that correct? Which is same as minus 1 I will take outside. Can you write it as 0 1? Minus 1 into 0 1. What is 0 1? Ket 1. So it is minus 1 into ket 1. Minus 1 extra we get. Minus 1 we get extra. Is that okay? See, ket 0 it is same as ket 0. Ket 1 becomes minus ket 1. This is called Z gate. Same thing. All these things we completed. No, Z not get 0. What is this answer? What is the answer here? 1 0. 1 0 means get 0. Thank you. Okay, your measurement probability which you know. What is answer here? Z on ket 1. Okay, answer also displayed. Okay, it is minus ket 1. Is that okay? Minus ket 1. If I measure, what is the probability of getting 0? get 1, can you write it something like this? Get 0 plus minus 1 into get 1. Is that correct? What is the probability of getting 0? 0. What is the probability of getting 1? Minus 1 whole square. That is 1. Probability of getting 0 is 0. Probability of getting 1 is again 1 only. Minus 1 whole square means 1 only. No change, no. Now similarly we have Harman gate. This is most important gate. There will not be any quantum lecture without mentioning Harman gate. That is most important gate. Again, once you know one gate properly, all other gates are same, only matrix is different, no? Now can you calculate? This is a matrix for this Harman gate. So can you calculate what is Harman on gate 0? Can you only calculate. What is Harman on gate 0? One gate, if you understand, all other gates same procedure. What is Harman on gate 0? What is Harman matrix you have known? You know that. What is gate 0 means 1 0. That also you know. You multiply both over. Completed? Thank you very much. 1 by column matrix 1 by root 2, 1 by root 2. 1 by root 2, 1 by root 2. That is in matrix form. In direct notation, that's all. Is that okay for everyone? Okay, now I directly display. See, Harman gate, this is the matrix. Is that correct? Like, get 0, what is the matrix? This is the matrix. You multiply both. Then we will get 1 by root 2, 1 by root 2. This we have discussed many times, multiple times now. 1 by root 2, 1 by root 2 is same as, see, alpha beta we write it as alpha get 0 plus beta get 1 no. Alpha beta we write it as alpha get 0. Both are same. Alpha plus 1 by root 2, beta plus also 1 by root 2. It is 1 by root 2 get 0 plus 1 by root 2 get 1. This is also known as plus state. Quantum state plus state. This is called equal superposition state. What is the probability of getting 0? 1 by root 2 square. 1 by 2. What is the probability of 1? 1 by 2. That's why both are coming with the same probability. No, that is called equal superposition state. Similarly, can you try for Harman on gate 1? What is the answer? Harman on gate 1. Harman on gate 1. Harman on gate 1, what is the answer? One by root 2 minus 1 by. That is matrix form, madam. Direct notation. Ket 1 is this one. Multiply both 1 by root 2 minus 1 by root 2. We know that alpha beta becomes again same thing. Alpha beta becomes alpha ket 0 plus beta ket 1. Alpha plus I have 1 by root 2. Beta plus minus 1 by root 2. Is that okay? This is called minus state. Is it equal superposition state or not? It is same as 1 by root 2 ket 0 minus 1 by root 2 ket 1. No. Is it equal superposition state or not? Is it equal superposition state or not? What equal superposition is? 0 whatever be the probability. 1 also same thing should be the probability of getting 1. What is the probability of getting 0? 1 by 2. 1 by root 2 square. What is the probability of getting 1? Square. 1 by root 2 square. 1 by 2. Both are same, no? Minus 1 by root 2 square. That is 1 by 2. Both are same. This is also equal superposition state. But both states are same. Does it mean that both are same? No. Minus is different. This is called ket minus state. Ket minus state. Minus state. Is that okay? This is all. What is the probability of getting 0? 1 by 2. 1. Also 1 by 2. Is that okay? Is that all this whatever I discussed now, they are called single qubit gates. Only one qubit is input. Now sometimes we can talk about 2 qubit gates also. We can similarly 2 qubit gates. Like AND gate, it is 2-bit gate, no? 2 bits we need to give as input. Similarly quantum also we have 2 qubit gates. 2 qubits must be input to for that gate. Are you getting that? Okay. Now one simple gate is controlled NOT gate. Simply it is called as C0 gate. C0, controlled NOT gate. Is that okay? This is 1 qubit gate or 2 qubit gate? It is 2 qubit gate. 2 qubit gate means matrix must be 1 qubit gate means 2 by 2 matrix. 2 qubit gate means it should be 1 qubit means 2 by 2. 2 qubits means 4 by 4 matrix. It should be represented using 4 by 4 matrix. 2 qubit states you don't know. What are 2 qubit states? Ket 0 0. This is represented as 0 1 0 0, no? 4 entries. That's why it should be 4 by 4 state. 1 qubit, 2 entries in the column matrix. That's why matrix should be 2 by 2 matrix. 2 qubit gate means 2 by 2 matrix. Sorry, 4 by 4 matrix. 3 by 3 qubit gate means 2 power 3 into 2 power 3 gate. 2 power 3 matrix. 8 by 8 matrix. 4 qubit gate means 16 by 16. 5 qubit gate means 2 power 5 by 2 power 5. Is it clear? Now all single qubit gates are represented by which matrices? Unitary. What is the order? 2 power 1 into 2 power 1. 2 by 2 matrices. Any single qubit gate is represented using which matrix? Unitary is standard answer. In that which matrix order? Single qubit, 1 qubit gate means 2 power 1 into 2 power 1. 2 by 2 matrix. X gate is 2 by 2. Z gate also 2 by 2. Similarly Y gate also 2 by 2. Hermod also 2 by 2. Whatever we discussed, all 3 are 2 by 2 only, no? Now 2 qubit gates. It should be represented by 2 square by 2 square. That is 4 by 4 matrix. Are you? This is a 2 qubit gate. Here this is input. This is output. Input, output. Here what happens is, input there are two parts. Okay? If the first one is 0, second one is not changed, as it is we get output. If If the first one is in 0 state, second bit is qubit that is not changed, the same answer we get. Are you getting? Now you tell me, first one is 0. This is called control, this is called target. If control is 0, target is not changed, yeah, it is whatever be the input, same output we get. If control is 1, this target is changed. 0 becomes 1, 1 becomes 0. Now you tell me 1 0 should become what? This is control target. Control is 1. This target changes. 1 0 becomes 1. This is control target. Control target. Control as it is. Target 0 becomes 1. 1 1 means control 1. 1 becomes what? 0. If it is 0 0.
0 1.
No, not 0 1. Control is 0 means target is not changed. Control is 1, then only target is changed. 0 1, 0 1. Same thing, no? It is represented by 4 by 4 matrix. How means the matrix is very easy. It is 4 by 4 matrix. 4 by 4 matrix means total 16 entries. This can be written as 2 by 2 matrix, 2 by 2 matrix, 2 by 2 matrix, 2 by 2 matrix. 4 2 by 2 matrices is automatically 4 by 4 matrix. 2 by 2 means 4 entries, 4 entries, 4 entries, 4. 4 plus 4 plus 4 plus 4, total 16, no? And this part is nothing but identity. Identity. Identity matrix means what?
1 0
1 0 0 1. 1 0 0. This is all zeros. This is also all zeros. This is control NOT gate. NOT gate, you know what is the matrix for NOT gate? X gate. NOT means X gate. What is the matrix?
0 1.
0 1 1 0. So this is the matrix for C NOT gate. Is that okay? I 0 0 NOT gate. Like that you can talk about control Z, control Y, control any gate you can talk about. In case of control gate, what happens is control is 1, target is changed. Input is control target, output is also control target. If control is 1, target is changed. If control is 0, target is not changed. If 0 0 is input, what is output? If 0 1 is input,
0
1 0 is input, 1 1 is input, 1 0. Is that okay? That's what. So this is 4 by 4 matrix. So any input, this is the circuit representation. So 0 0 is input. 0 0 means this is the matrix. After that it is only matrix multiplication. Everything. You multiply with that, you get some state. Okay, no? Then you get 0 0. Similarly 0 1 you can try. 1 0 like this, all 4 you can try. Is that okay? This is control NOT gate. Now, in order to use our protocols, quantum communication protocol, which we talked about, that is like superdense coding and the quantum teleportation. First, we need to create entangled qubit. 1 by root 2 get 0 0 plus 1 by root 2 get 1 1. To create that, this is the procedure. This is the procedure. After that, we get this state. Then this state we use in this protocol. Okay, now this protocol, these are the steps. What for this protocol is used? To send two classical bits by sending 1 qubit of information. By sending 1 qubit, we send 2 classical bits of information from one source to destination. For that, this protocol is used. Okay. So it is possible to send 2 classical bits of information by sending only 1 qubit. Yes. Which protocol we use? Superdense coding protocol. Okay, no? Yes, by using superdense coding protocol. And these are the steps in this protocol, and it was proposed in the year 1992 by Bennett and others. Okay, now this that. And these are the steps. These 5 steps in this protocol. 6 steps in this protocol. So finally, if you send 0, 0, sender sends, ally sends 0, 0, Bob has to receive 0, 0. Ally sends 0, 1, Bob has to receive 0, 1. Ally sends 1, 0, Bob has to receive 1, 0. Ally sends 1, 1, Bob also has to receive 1, 1. All these locations I have applied. Okay? And this is the circuit diagram for that protocol. So this is superdense protocol. Next one is quantum teleportation. What for quantum teleportation is used? To send a qubit from one side to another side. For that quantum teleportation is used. What is no cloning theorem? You might have heard. It is impossible to create a perfect copy of unknown quantum state. If you don't know quantum state, another replica not possible. See, it is not possible to copy. Copying is not possible. No cloning theorem states that. Is it possible to send a qubit from A to B? That qubit will be lost. Only B will receive that. That we can do it by using quantum teleportation protocol. And these are the steps in that protocol. Finally, once you know all these things, then people can talk about quantum. This protocol was proposed in the year 1993 by again Charles Bennett, IBM research fellow at that time. Okay. This is the circuit diagram, and these are the steps. Ally sends and Bob receives all those things. Next, finally, we can talk about quantum internet also, quantum networks, with that secure communication, all those things. See, this is the structure, architecture of quantum networks, and for this secure communication, all those things we can do. Okay. And these are the topics I have discussed. Okay, no? And these references I forgot, I think. Okay. References I have not given. Thank you very much for being attentive and giving answers. Okay.